There is also the rabbit hole that many experts talk about, which is automated retraining. And the narrative that has been pushed over the past few years is that more data, and maybe also more recent data, is always better, which is not necessarily the case. And specifically for demand forecasting, there is this thing where you increase your training window, that you have more data. It might increase your performance, but it might also have a negative impact on your performance, because if patterns are changing very fast, we're including data that is no longer relevant for the problem that we're solving. And when it comes to MLOps maturity, there's also this narrative that's being pushed, like, the more advanced we are and the more we do automated retraining, the better it is. But the most catastrophic failures that we've actually observed over the past few years that we're doing machine learning monitoring is often the case when there's lots of automation and limited observability. And what does that mean? If you automate lots of things and you, for instance, retrain weekly, is that you also expose yourself to some of the risks that come along with automated retraining. Because, for instance, when there is a data quality issue, there's one thing to make bad predictions on bad data, but there is another thing to then also include that bad data in the retraining of your next model. And then these type of problems can propagate through the life cycle of the machine learning model. And when we retrain, the new model might not always be better. And specifically, if we have not validated our retraining schedule, or we've picked an arbitrary window, or we picked an arbitrary frequency of retraining, we might actually, the variance of the model performance might actually increase and also bring unnecessary computing costs with it. So this is really something that we've seen, that the whole automated retraining movement, it is something to be cautious about. And that's also been confirmed by other people, and specifically in the demand forecasting space.